Hello, welcome back. This is the second video on Twisty Puzzle Math. What we're going to do now is introduce the concept of a group and also, well, we'll see where we go from there, I suppose. So a group is a mathematical object, and the moves that you do on the cube form a group. So all the things, the legal things, to do to the cube, right? Moves, twists, all the things you can do to the cube, form a group. They act on the cube, moving the cube from one state to another. So I have a cube, and I do something to it, and now the cube is in a different state. I can do something else to it, now it's back to the original state. But you're always taking the cube from one state to another through these moves. Now, a group, a mathematical group, is just a collection of things that has a binary operation. I'll explain what these things are and demonstrate them in a moment. It's a binary operation. It's closed under the binary operation. Every element has an inverse with respect to the operation. There's an identity with respect to the operation. And the operation is associative. So let's talk about what these things mean. So the things in the cube group are just moves. So if you have two moves, say P and Q aren't faces. P could be some combination of R's, F's, U's. Q could be some combination of L's and U's and D's and B's and so on and so forth. If you have two moves, you can combine them to make a new move. So that new move might be PQ, for example. And this is a move, all right? And so it belongs in that collection of moves. So this collection has all the possible moves in it. If you took any two of them and you do P and then do Q, you have another move which was already in your collection. That's what closed means. Any two things in here are combined to give you yet another thing. An inverse just means if P is a move, there is a P inverse, so that P inverse equals an identity. So you have to have some identity element, okay? And each element in your group has to have an inverse so that when you multiply them or concatenate them, you have the identity. So anything you do, say this move, right? I should maybe say what that is. So if I did an L, U, L prime, of course I can always do that backwards. I can do an L, U, L prime, and it brings me back to the initial state that I was in. Now this state, the solved state, isn't itself the identity. The state of the cube isn't a member of the group. The things we do to the cube are members of the group. And so the identity is a move that does nothing. So it's a very boring move to watch. So here is the identity move. See, nothing happened. So the idea is if you have a process and do its inverse, it's as if you did nothing at all. Now associativity I'm not going to bother with. I mean, all that means is that if you have three moves, P, Q, and R, you can group them. PQR is the same as PQR. And it's not going to have a lot of consequence for us. If I could, I'll spend a moment on this. There are equivalent moves in the cube group, things that do the same thing. That some might be longer than others. So you could replace PQ with some other move Z, and that would be the same as replacing QR with some move Y if they do the same thing. And then ZR and PY would be the same. So it's not terribly important for what we're doing. The punchline here is that you don't have to know this to play with the cube. It just turns out that the things that you do to the cube themselves fall under this thing called a group. Now, lots of things are groups. Numbers, adding numbers together, multiplying numbers. These things are groups. Symmetries of squares are groups. There are lots of groups used in theoretical physics, symmetry groups. So the idea of a group, mathematically, one, it's a very general object, and it has many applications. This is just one of them, and when we're talking about the mathematics of the cube, we're referring to group theory. Alright, so that's the definition of a group and how it applies to the cube. The next video, we'll go over commutators and conjugates, and also the notation, the cycle notation for describing a process on the cube.